Now here I will try to discuss the new terminology in this case, and that terminology is nothing but the tree. I will go through the definitions and then I will show one example, because hereafter we are in a position to find out many trees, because the solution for this particular network solution of the problems using the network topology is not possible unless and until you are aware of this concept, which is nothing but the tree. Is it right? How is the tree? That definition I will discuss. Look at here. This tree is a definition. It is related to the graph. It is related to the graph. Graph may be directed or it may be undirected graph, but generally we will consider the directed graph. It is a set of the branches of the graph which connects each node to other node directly or indirectly without forming a loop or closed path. Means we have to connect one node to the another node directly or indirectly with minimum set of the branches, and that minimum set of the branches will not form the loop. Then that part of the graph is known as a tree. That part of the graph is known as a tree. I will discuss that definition of the tree, and then I will come back to the slide to discuss the number of branches in the tree and the concept of the twig. That I will come back to you later. But I will come to this figure again. This is the reference figure which I am planning to consider. Is it right? Now I want to draw the tree for this given graph. Or maybe sometimes they may ask for the given circuit, draw the oriented graph and find out any one tree. We will find out the tree. We can find out the tree. Here, what is the procedure for finding the tree? First, draw the nodes as it is. This is one node, this is the second node, this is the third node, and this is the fourth node. I will give the names to the nodes also. This is A node, this is the B node, this is the C node, and this is the D node. Now here, connect all these branches to each other, or all these nodes to each other. Connect all these nodes to each other. Are you able to see my screen? Yes, all of you. Yeah. Now here in this case we have 1, 2, 3, 4 nodes. Now in this figure, connect all these nodes in such a way that there should not be the formation of loop. Now look at how will be the simple terminology. This is one branch, this is the second branch, and this is the third branch. Is it right? Means this is the branch number 2, this is the branch number 3, and this is the branch number 5. Its direction is a forward, its direction is a downward, and its direction is also forward. Now look at. We have connected 1, 2, 3, 4 all nodes to each other directly or indirectly without forming the loop. There is no loop. If I am putting this branch, then there will be the formation of loop. If I am putting here branch, then there will be the formation of loop. Then this is I am putting this branch, then there will be the formation of loop. Means we have to connect each point to or each node to other node directly or indirectly without forming a closed path. That part of the graph is known as a tree. That part of the graph is known as a tree. And that particular graph has many trees. This is one tree. This is one tree. We have so many number of the trees. What is the number of tree? I will discuss. How many possible number of trees? I will discuss later on. Because right now you may not be able to understand. But I will draw another tree for the same graph. This is one simple tree. Generally, the tree may be given in the examination to find out the solution of the particular current branch. Is it right? Suppose these are the 4 nodes. This is node A, this is node B, this is node C, and this is the node D. There may be another combination of the branches which may be connected to all the nodes will be connected to each other directly or indirectly without forming a loop. It may be something like this. This is one path. This is second path. Or this may be the third path. This is the branch number 1. This is the branch number 3. And this may be the branch number 6 or maybe 7. I'm taking it as a 6. Now look at, in this case also, we have connected all the nodes to each other directly or indirectly without forming a loop. This is also the tree. This is also tree for this given graph. This is also tree for the given graph. I will draw another tree and then I will conclude this point. Here, suppose we have, this is the branch, sorry, node number 1, this is node 2, this is node 3, maybe it is the 4th node. It is the 4th node. How will be another tree? I will draw. This may be the one path. This may be the another path. And this may be path from here or here. I will draw this. This may be the another path. Now, in this case, look at the direction. This is the branch number 2. This direction is a forward. This is the branch number 8. Which direction is a forward? And this is the branch number maybe 6 or 7. One and the same thing. Because if we are taking the 6 and 7, the things will be the same. Now look at, in this case, this is node A, this is node B, this is node C, and this is the node D. All the nodes are connected to each other directly or indirectly without forming a loop. There is no formation of the loop. That's why this is also the tree for given graph. This is the tree for given graph. Now here I will come back to the slides and then I will discuss about this particular point. Now look at carefully. For this given graph, how are the case? This is a complete graph. This is node A, this is node B, this is node C, and this is node D. What is our aim? Our aim is to connect all the nodes to each other directly or indirectly without forming the loop. And those set of the branches is known as a tree. You see here, the lines which I have shown by the red color, this is 1, this is 2nd, and this is 3rd. It will connect a node A and D. This is A, B, and this is B, C. Means we have connected all the nodes A, B, C, and D, and there is no formation of the loop. This is 1, 2, 3. This is 1, 2, 3. These are the 3 branches forms the tree. This is 1, 2, 3 is a tree. In this case, this is 1, 2, 3. It is also tree. This is 1, this is 2, this is 3. It is also tree. This tree is the set of the branches. Look at definition. It is a set of the branches of the graph which connects one node to each node to the other node directly or indirectly without forming a loop or closed path. I forgot to mention one word here. It is a set of branches with nodes. With nodes, because in the tree we will show the nodes also. The set of the branches together with the nodes is known as a tree if there is no formation of the branches with nodes. Together with the nodes. Set of the branches together with the nodes which will connect each node to the other node directly or indirectly without forming a loop or closed path is known as a tree. Is it right? This is tree. Then there is a relation now, there is a formula for calculating the number of branches. The number of branches in any tree is given by the formula n-1, where n is the number of nodes. How many nodes we have here? 1, 2, 3, 4, 4 nodes. This 4 minus 1 is the 3 branches we should have in a tree. This is 1 branch, 2nd branch, 3rd branch, 3 branches, 1, 2, 3. This is again 1, 2, 3. This is forming a tree. Is it right? As well as, if I'm coming back to this figure, how many nodes we have here? We have, it is 1, 2, 3, 4 nodes. And what is the formula? Formula is n-1. Formula is n-1 because 3 branches Tree branches is equal to n minus 1. Means how many branches we should have here for a given tree? That is 4 minus 1, which is equal to 3. Look at here. 1, 2, 3. Here it is 1, 2, 3. 1, 2, 3. Yes, we should have 3 branches in the tree for this given graph, and it depends on the number of nodes. It depends on the number of nodes, and formula is n minus 1. And I will take another definition and then I will come back to you. Twig. Tree branches are also known as a twig. Now here, this is also known as a twig number 1, twig number 5, twig number 4. This is twig number 5, twig number 2, twig number 4. This is the twig number 1, twig number 5, twig number 6. Means another name for tree branch is the twig. Means whenever there is a word in the problem twig, twig number 1, means always that is the tree branch. Is it right? There is always the name twig indicates the branches of the tree. If I am selecting or if I am giving, take the twig 154. Take the twig 154 and find out the solution. Means indirectly they will give the tree to you. Means we have 1, 5 and 6. We have to take it as a tree and then we have to find out the solution. Because while finding the solution of the problems, while finding the solutions to the problems, first we have to select the tree. This is another definition, cotree. The branches of the graph which are not selected in the tree together with the nodes is known as a complementary tree or cotree. I will first discuss this with the figure which I have selected on the paper, and then I will come back to this definition. I will come back to this definition. Yes. Yeah. For this part, now look at how will be the cotree. Cotree is for a particular tree. Cotree is for a particular tree. I will consider this part of the graph. I will use this portion. Yeah, here. Now look at how will be the cotree for this tree. How many nodes we have here? For the selected figure, we have 4 nodes. This is node A, this is node B, this is node C, and this is node D. Is it right? I have taken this 1, 2, 3 branches as a tree. Excluding those 3 branches, maybe this branch, maybe this branch, maybe this branch, and it is this branch. This direction is a downward. This is the branch number 1. This direction is a downward. It is branch number 6. This is downward, branch number 7. And this is a forward, which is the branch number 8. This is the branch number 8. Start again. Now here in this case, now look at branch number 1, branch number 6, branch number 7 and branch number 8. This forms a cotree for this tree. This is cotree, or it is also known as a complementary tree. Because the finding the solution for the problem using the network topology depends on the 2 basic concepts. You must be clear with the concept of the tree and cotree. Tree is the set of the branches which connects or together with the nodes which connects each node to other node directly or indirectly without forming the loop is a tree. And the set of the branches together with the nodes excluding the tree branches or twig is known as a cotree. If it is ABC and this is D, in that particular case, this is cotree for this particular tree. Is it right? Then I will try to draw the cotree for the second tree. I will draw the cotree for this second tree. Is it right? Just I will draw the cotree for the second tree. How it will be? I will take this part. Is it right? For this figure, third figure, how will be its cotree? This is node number 1, node number 2, node number 3, and node number 4. I will call it as node A. This will be the node B. This is node C, and this is node D. If it is a cotree, if it is a tree, and how will be its cotree? We have to select all the branches excluding 1, 2, 3. This here may be this branch. Here will be this branch. Here will be this branch. Is it right? Then what are the left? We have considered this branch 2, 8, and 6. We have excluded this, and branch number 6. Yes, there is a fifth branch. Is it right? This branch. This branch. Its direction is downward. Its direction is downward. Its direction is downward. This is the branch number 7. This is the branch number 7. This is the branch number 3. This is the branch number 1. And I have taken this, and this is the branch number 5, which is the forward. Is it right? Better way, count the number of branches. 1, 2, 3, 4, 5, 6, 7, and 8. Is it right? In this case also 1, 2, 3, 4, 5, 6, 7. Here also 1, 2, 3, 4, 5, 6, and 7. This count of the branches in this figure is the addition of the cotree branches and tree branches. That is, I mean to say. Is it right? This is the cotree for this part of the figure. Similarly, for this particular figure, we can draw the cotree. I will draw here. For this particular part of the graph, or for this particular figure, this is the node number 1, this is the node number 2, this is the node number 3, and this is the node number 4. It may be the A, this is B, this is C, and this is D. How is this cotree? I have taken this 1 number branch. That's why 1 should not be there. Here is a 2. This is 2. I have taken this 3 here. There is no 4th branch. I have not given the 4 name. Then it is a 5. This 5 is here. This 5 is here. 6. I have taken the 6. 7. Here is the 7. This is the 7. Branch number 7. And there is 8. And this is the branch number 8. This is the branch number 8. This is the branch number 2. This is the branch number 5. Means if we are excluding the branch number 1, we have taken the 2, we have taken the 3. I have not given the name 4. Then this is 5, this is 6, this is 7, and this is 8. And we have covered all the branches. Otherwise, count its number 1, 2, 3, 4, 5, 6, and 7. We have the 7 branches in this particular case. Though your number is looking to be 8, but by mistake I have not given the name, which is 4. That's why it is a name. That's why no need to bother about that much. Is it right? This is the cotree. This is the cotree for that particular figure. This is cotree. This is cotree. Means part of the graph together with the nodes excluding the tree branches is known as a tree. That is the definition of the cotree. This here, whatever I have drawn, these are the cotrees for the trees which I have selected here. In this particular case, this is tree, it's cotree. This is tree, it's cotree. And this is tree and its cotree is here. These are the tree and cotree branches. Is it right? This is the second number, this is second, this is third, this is third. This is the concept of the tree and cotree. I will come back to you. I will discuss in the figure and then I will proceed further. Is it right? This is cotree. Now here, if it is a tree, 1, 2, 3, this is tree, then red lines are cotree. If it is 1, 2, 3 is a tree, that 1, 2, 3, this remaining 3 lines are the cotree. And what is the name given to the cotree branch? It is known as a link or cord. The cord or cotree branches are also known as a link or cord. If I am calling this tree as a link or tree as a cord, means obviously it should be the cotree branch. If I am calling the branch number 2 as a twig, it should be the tree branch. In this figure, I cannot call this 2 as a twig. Because in this case, this 1, 2, 3, this branch number 1, branch number 5, branch number 4 is a tree. That's why the branch number 2 is the cotree branch. That's why it should be called as a link or cord in this particular graph. It may be the different name here. Is it right? But that is the philosophy of the tree and cotree branches. Of the tree and cotree branches. Now here, there is a formula for number of cotree branches. What is the formula? I will show. I will show that and then I will discuss. Here, the procedure for constructing a tree, I have already discussed. How is the procedure? We will discuss. How is the procedure? Draw all original nodes. Generally, we will draw the nodes 1, 2, 3, 4, whatever. Add the branches till all the nodes are connected without forming a loop. This we will add something like this. This is something like this, and this is something like this. We have connected all the nodes. This now, without forming a loop, that is nothing but the tree. The possible number of tree is nothing but A into A transpose. A into A transpose. Where A is the reduced incidence matrix and A transpose is the transpose of the reduced incidence matrix. Right now, I have not discussed about the incidence matrix or reduced incidence matrix. Whenever I will discuss about this in that particular case, we are able to find out the number of possible tree. क्योंकि यहाँ पे मैंने आपको फिगर में कितने trees दिखाए? In this particular case, I have shown for this particular figure 1, 2, 3 methods I have shown, as well as जो मैंने figure मैंने paper पे draw किया था. How many trees I have shown? 3 trees only for a sample. But the number of the tree or possible number of the trees is more than that, and it can be calculated by using this formula. The graph having n nodes and b branches, number of tree branches will be n minus 1. I have already discussed this formula. Number of tree branches will be n minus 1. Now, number of cotree branches. What is the formula for the number of cotree branches? Number of cotree branches formula will be total number of the branches minus number of tree branches will be the cotree branches. Means b minus number of tree branches, and tree branches are n minus 1. Means someone can use this formula. ये दोनों formula में confuse नहीं होना है. That's why I have written this here itself. B minus in bracket n minus 1. Otherwise, B minus n plus 1. You can use this formula or you can use this formula. But always I will prefer this formula because this formula में confusion हो सकता है because we are taking n plus 1 here. Because n minus 1 is the number of tree branches. B is the total number of the branches. Total number of the branches minus tree branches will be the cotree branches. Means for this previous figure, how many total branches we have? 1, 2, 3, 4, 5, 6. 6 branches. Means in this particular case, how many tree branches we have? 1, 2, 3. Means how many cotree branches will be there? 3. Because total number of the branches are 6. The number of tree branches are 3, which is 6 minus 3, which is equal to 3 is the number of cotree branches. Similarly, if I am coming back to the figure which I am trying to discuss with you continuously, which is this figure. Now look at in this figure. How many total branches we have? 1, 2, 3, 4, 5, 6, 7. We have the total number of the branches. Means B is the 7. How many tree branches we have? 1, 2, 3. Tree branches are the 3. That's why cotree branches is equal to here cotree branches. This is equal to number of branches, which is 7, minus number of tree branches 1, 2, 3. This is 3. Means which is equal to 4. Now look at here. If I am taking this cotree, this is 1, 2, 3, 4. Means we have the 4 branches for that cotree. Here, look at here. 1, 2, 3, 4. There's 4 branches we have for that cotree. Here also, this is 1, 2, 3, 4. We have the 4 branches for that cotree. Means what is the formula for the number of cotree branches? The formula for the number of cotree branches is nothing but this. Total number of the branches minus number of tree branches. I will always prefer to use this formula because in some books this formula is also given, but you should not confuse with this formula. Always try to use one of the formula. I am using this formula, that is number of branches minus tree branches is nothing but the cotree branches. This is the basic concept about this. Now, properties of the tree. Tree contains all the nodes. Tree does not have any closed path or loop. In a tree, there is only one path between any 2 nodes. In a tree, minimum number of the n nodes is the 2. minimum. Maximum may be the higher. Suppose we have this is one node, this is second node, this is third node, and this is fourth node. We have here, suppose this is the branch number 1, this is the branch number 2, and this is the branch number 3. Suppose it is one tree. This is one tree. Here, tree contains all the nodes. We have this one A node, B node, C node, and D node. Tree does not have any loop. Here is no closed path. There is only one path between any two nodes. Suppose we want to travel from suppose this A node to this B node, because this is the B node. Suppose this is the B node and this is the C node. If we want to travel from A to D, we have only one path. We have only one path, which is this. We have only one path, which is this. We have only this path. Or if we want to travel from C to D, there is only one path. If we want to travel from A to B, there is only one path. If there is only one path between any two nodes and minimum number of the end nodes. What is the end node? इस नोड के बाद बाकी आगे कुछ branches नहीं है, that is known as the end node. This is end node, this is also end node, this is end node. What is the requirement? Minimum will be the 2, but it may be greater than 2. Is it right? Now here in this case we have this is 1, this is 2, this is 3. In this particular case we have the 3 end nodes. This is not the end node, because from this node branches are moving to any direction. It may be from this direction, this direction, this direction. But here from the end node, only incoming or outgoing branch will be there. There is no further connection between the nodes. Is it right?